Now moving to the back of the notes for sine and cosine ratios, we're going to look at the special right triangles in relationships with sine and cosine. So first I'm going to show you our chart. I have sine and cosine highlighted in pink, and I want you to notice something about sine and cosine 60 degrees. One is 0.866, the other one is a half. And if I show you 30, notice what happens. This one is now 0.5 and this one is the 0.866. So if you'll notice, they flip-flop. And now if we look at the 45 degrees, they are the same exact thing. So we are going to examine the relationships of why that is happening. So first we're going to look at the 30, 60, 90 triangle. So if this is a 60, we know this is 30. And by using our special right triangle rules, opposite of the 30, that is the short leg. The hypotenuse is double that, and the long leg is 1 times the square root of 3. So it is just square root 3. So if I do sine 30, that is going to be opposite over the hypotenuse, so there is the 1/2. If I do sine 60 degrees, that is opposite over the hypotenuse, which is square root 3 divided by 2. And to show you what that is on our calculator, square root 3 divided by 2 is the 0.8660 number. Now why would the cosine 30 and cosine 60 just be switches of that? Well, it's just simple math. If we go to cosine 30, that's actually the same as sine 60 because cosine 30 is the adjacent leg over the hypotenuse. So you can see right there we have the same thing. It's the same trigonomic ratio. And if we do cosine 60, which we move up here, and we do adjacent over the hypotenuse, we get 1/2, which again is the same thing. So that's why in the chart, we can see here in this chart, they just switch because it's just all about the reference angle. Now moving to the 45-45 degree, 45-45-90 degree triangle. Remember, this is going to be 45. If this is 1, this is 1, and this is the square root of 2. So sine 45, well, they're both 45, so it doesn't matter where we go. It is opposite over the hypotenuse. Remember, we can't have that square root 2 in the denominator, so we rationalize, and we get square root of 2 over 2. So now if I check that on our calculator, square root 2 divided by 2, I get the 0.7071. And then again, cosine 45, it's adjacent. Well, the legs are the same thing. So it is 1 over the hypotenuse, so adjacent over the hypotenuse, that is still going to give me square root of 2 over 2. So the relationship stands. And we will actually look at this relationship more with day 2 notes. Now, the next thing we're going to tackle is going to be angles of elevation and angles of depression. So first, angles of elevation. When looking up at an object, the angle your line of sight makes with the horizontal line is called the angle of elevation. It is very important that you know this is coming from the eyes, and there is an angle right here. This angle, your eyesight goes forward. The angle when you're looking up to something is called the angle of elevation. We have a right angle being formed with this tree. Now, the angle of depression is when you are looking down at an object. So here's a person on top of the building looking down here. It's got to come from your eyesight. It makes a horizontal line, and that is called the angle of depression. Okay? Now, here is one from a cliff. This does not have the eyesight, but it's with the cliff. There's the angle of depression. Now, this is the connection that I need for you to make. So if this is the angle of depression, this is the angle of elevation. We actually have alternate interior angles going on. So let's say this was a ball on a cliff, this was a person's eyesight down here, the angle of depression would be here, but the angle of elevation's here. So a lot of times these go hand in hand because they are alternate interior angles. Now, the key to this type of problem is drawing a picture. So the first time I'm going to give us a picture, but if you'll notice 7, 8, and 9, I do not give us a picture. So this is the part where you've got to be able to visualize what they are presenting. So first, question 6. A railroad crossing arm that is 20 feet long is stuck with an angle of elevation of 35 degrees. Find the lengths X and Y. So for here, they give us a picture. They clearly tell us this is the angle of elevation. We also now can find this one if we want to, but we can find everything we have simply by using this one thing. So if I look at 35 and I'm trying to find X first, X is opposite and 20 is the hypotenuse. So that tells me to use sine. So sine 35 degrees equals opposite over the hypotenuse. I'm going to cross multiply. So X equals 20 times sine 35 degrees. And I'm going to use the calculator now to calculate this. 20 sine 35 degrees is going to give me X is approximately 11.5 feet. Now, for accuracy, I am not going to do the Pythagorean theorem because this is now rounded. I could to find Y, but it is actually quicker just to use cosine now because this is the adjacent leg and that's the hypotenuse. So we don't have to do the Pythagorean theorem. We can just say cosine 35 degrees equals adjacent over the hypotenuse, which is 20. Cross multiply. Y equals 20 times cosine 35. Again, use the calculator to calculate that. 20 cosine 35. And I get Y is approximately 16.4 feet. So you will come to learn that the sine, cosine, and tangent ratios actually are a lot quicker in solving problems. Now, question 7 is going to be, can you draw this and then ask or figure out what it's asking you to do? It says a homeowner is to construct a ramp in front to his front door to make it wheelchair accessible. How long is the ramp if the door is 4 feet above ground level with an angle of elevation of 20 degrees? So the first thing you need to do, draw that ramp. That's the ramp for the wheelchair. It's clearly telling you an angle of elevation. So that is how that angle's coming off the ground is 20 degrees. And this ramp is going to come up against a house. And now you've got to label what you know. It says the ramp, how long is the ramp? This is the ramp, so I'm going to place X there. Door is 4 feet above the ground. So there's 4 feet above the ground. And it says now to go ahead, how long is that ramp? So we ask ourselves again, here's 20. We have an opposite and we have a hypotenuse. So again, we are going to do sine. So sine 20 degrees equals 4 over X. Cross multiply. X times sine 20 degrees equals 4. Divide by sine 20 degrees on both sides. X is approximately. Now go to your calculator. 4 divided by sine 20. That is going to be approximately 11.7 feet. 11.7 feet. Now, those are what I consider the more simple problems. Now, question 8 involves a lot more math. So I'm going to say, drawing a picture for these, this is where we've really got to stop and pay attention to what's going on. So I want you to read them, and I want you to see if you can draw the pictures before we move on.